little bit of muscle damage is good because what do?
It builds back and
Yeah, we stress the muscle, we come back and do what? Make it stronger, right? Okay, and so now there's different forms of, or isoforms of creatine kinase. There is a heart enzyme, and if they think you've had a heart attack, that means you have what in your muscle? Heart muscle damage, right? And they'll take a blood test and see, look at your creatine kinase level and see what it is. If your creatine kinase level is up, that means you've got heart damage, heart attack, or whatever. And so that's one way they look at it. They look at it other ways too, but they do that. So if you're a personal trainer, do you want to cause muscle damage to your person where they can't even walk up the steps, or they can't even raise a weight, or they have to go to the doctor, or they're so sore they can hardly move, or whatever, right? And so, no. And so you don't want to, you don't want that to happen there. And so the old school people, they used to tell us that lactic acid was the reason people got sore. False. It's not true, right? Because whenever we do curl ups or whatever, our lactic acid level goes up, and then in a minute or so later, it's reconverted back into glycogen and it's gone, right? So we've measured muscle lactate in the lab a lot of times. And so let's say you're running on the treadmill or whatever, your muscle lactate gets up to like, say 10 millimoles, okay? 2 hours later, it's down to like 1 millimole, resting levels there, okay? So lactic acid does not cause muscle soreness, right? It may cause the muscle to burn while you're working out, but it does not cause muscle soreness. Has anybody ever taught you that lactic acid causes muscle soreness?
Yes.
Who? Biology people?
High school.
High school?
Especially.
Yeah, so it's not true. Lactic acid is converted back into fuel. Lactic acid is good, and so it's a byproduct of anaerobic exercise. And so whenever we exercise anaerobically, it starts to creep up and creep up and creep up. Then it gets to a certain level where it decreases our performance, and we burn. The muscle burns, right? And so whenever you do a max reps on sit-ups or curl-ups, what's going to happen to the muscle? It's going to burn, right? And that means you're working anaerobically, and you're producing what? Lactic acid. The good thing is you produce it, then you train for a few weeks, then you're able to produce more lactic acid and still tolerate it. And then the body can tolerate more lactic acid, and you're able to be more fitter or stronger or run faster or whatever you do. Post-exercise, it's good to jog or walk after you get through exercising, because when you do that, you take in what? Oxygen, right? Oxygen plus lactic acid is converted back into carbohydrate. Okay, and so you see those guys on the field, they get on a little bike and pedal a little bit and so forth, and the games and stuff. Why are they pedaling that? It helps them recover. It helps them get rid of lactic acid and so forth, and so it helps them recover quicker. So oxygen is your friend, and even anaerobically, if you take in oxygen, it helps you do what? Recover, right? And we're talking about low intensity exercise, and so if you're running and produce a high level of lactic acid, then you slow down to a jog and jog a little bit, then you get rid of the lactic acid, and then you're able to do what? Jog again, right? And so forth, as long as you don't go too fast. And so it's good to recover, get rid of the blood lactate, and then you're ready to go again. But we measure those things, and it's been measured like tons and tons and tons of different times there. Now muscles are like springs. This muscle right here can only move in what? This direction and this direction, right? You can't move sideways. If we're going to do sideways, we got to have another what? We got another muscle over here that does sideways stuff, right? So, whenever, let's say I do a leg extension, okay. What muscle do I use? Quads, right? And what muscle relaxes? Hamstrings, right? Okay. So one contracts and the other does what? Relaxes. What happens if they both contract at the same time?
Falling over.
Huh?
Are you falling over?
No, you're not falling over. You are hurting. And that's how you get a muscle cramp. Hydration is not anything to do with muscle cramps. It doesn't mean that you're dehydrated. Okay? And we just learned that. Okay? And so, not too long ago. And so then they go in, and what do they do to the muscle to get rid of the cramp?
They relax.
Stretch it, right? And then that gets it back where one's relaxing and one's what? Sort of contracting there. And so, all of you had muscle cramps? Were you dehydrated? Maybe yes, maybe no. Yeah. Because remember, the signal goes from the brain, from the central nervous system to the muscle, makes it contract, and then as one contracts, the other one is supposed to do what?
Relax.
And what do we call that?
Muscle.
It's called
tension.
reciprocal innervation. Yeah. I don't think that has anything to do with it. Not the latest science doesn't show that. So, well, you know, it could have something to do with it, but whatever's happening is making those muscles both contract at the same time. Okay, and so.
So does that mean it could be like multi-factored, like why it's happening if it's related to nervous system?
Yeah, something's got your nervous system messed up. Okay, and so whenever we start an exercise program, we all get stronger because we learn how to do the exercise, right? Because if you've never played golf before and you come up here to hit a golf ball and you tighten every muscle up, that's as far back as you can take the club. You sure can't hit it very far. So what do? You've got to relax and only use what? The muscles that you use to hit the ball, right? So if you ever watch the baseball players, it looks like they swing like this and they hit a home run. And so because they're only using the muscles they need to do that particular what? Movement, right? If you get other muscles involved, they get in the way. And so that's why learning the skill is really important, to make sure you use the right what? Muscles to lift the weight or kick the ball or whatever. If you're stiff and tight and everything contracts at one time, it messes you up. If you're trying to shoot a free throw to win the game and you're all stiff and tight, forget it, right? What if you got to do a PK and you got to get it to win the game with like 10 seconds left? Can you be stiff and tight? You better be relaxed, right? And you better done it before in stressful situations, and so your brain doesn't screw you up, and so and that's why things become automatic, right? And so you don't need to think about it. You put the ball down. Okay, I've done this 1,000 times. Zip right in the net, right? Is that what you do? Yep. So that's what you do. And we have gross motor skills, and we have fine motor skills, right? And so if we look at the nervous system and the muscles, your fingers are like fine motor skills, right? Okay. And so based upon the neurons that go to them, they can really manipulate and so forth and do fine motor kind of skills. Probably never, any of you ever sewed before?
My mom.
Before you sew, you got to thread the needle. You ever tried to thread a needle? That's a fine motor skill, right? That's why they got little devices that thread the needle for you. So I remember when I was a kid trying to thread a needle, it was like, oh,
Now
this
they
is
make like bigger little loops on.
bigger holes or something, and got a little needle threader device and so forth. And so, you know, used to we had to sew up holes in our jeans. Now people just cut holes in their jeans, right? And so things have changed. But that's a fine motor skill. A gross motor skill is when you punch somebody, right? And so you don't need as many motor units going to the muscle to punch somebody as you do to what? Thread a needle, right? And so it's all based upon the nervous system recruiting the right muscle fibers in order to do whatever you need to do the skill or task or whatever you do. What's easier to repeat, fine or gross motor skills? Gross motor skills, right? And so if you use your big muscles, it's easier to repeat things over and over and over again. If you use little fine motor muscles, it's harder to repeat things over again. Okay? And so, because of the nervous system there. So, like a football lineman, do they need gross or fine motor skills?
Gross.
Gross motor skills, right? They just get up there and grunt and hit the guy in front of them, right? The quarterback needs what? Tom Brady needs what? Fine motor skills, right? To throw that pass exactly where that guy can catch it and so forth. And so different sports activities need different types of motor skills. They need different numbers of motor neurons and so forth in order to do particular types of skills there. And so we look at that when we look at muscles, and there's a whole major that you can take related to people that study that. What's that major called? Called motor development. So you go to Auburn and you can major in motor development and talk about motor skills and so forth. It'd be a good thing to do. Good major. A lot of interesting kind of stuff there. So muscles are dependent upon the nervous system. If we don't send a signal, electrical signal, to the muscle, will never contract. So if somebody becomes paralyzed, why are they paralyzed?
Because their nervous system is.
The nervous system is not sending a signal to the muscle to make the muscle work or contract there, right? And so, if you're going to be a PT or whatever, you're going to have to take, study you got to know where every nerve is, right? And you got to know how to measure the force. And you need to have to measure where those nerves are, and there's pain associated with that nerve, how to take it and treat it and deal with it. And so you have to take gross anatomy, and so most places have cadavers where you go in, you got a body laying on a table like this, like a stainless steel table, and you take that body and you start slicing on it and so forth. You take it apart and you learn every little muscle and every little tendon and every little part of the body. That's the first class you take in most PT programs. They figure if you pass that, you can make it through the program with no problem there. And then the next class you take is neuroanatomy. And so in that class, you learn all about the nervous system and where those nerves are or whatever. One tip is, if you get a cadaver, don't get a fat cadaver. Because you got to slice all that fat away before you can get to the muscle. And so those are nasty cadavers. You want a nice slim cadaver, okay? So one that is lean and so forth, and easy to study there. Okay, let's take a quick break.